In this video, we're going to talk about applications of quadratic functions. Here are some problem-solving strategies that we are going to follow. Of course, the first thing we need to do is read and understand the application. And sometimes we'll need to read it more than one time. Step 2. Identify the independent and dependent variables based on the given function. So we are going to be using variables, and we will define those variables as being either independent, which is input, or a dependent variable, which is the output. Step 3, determine the y-intercept by letting x equal 0. That's important to us because it will generate an ordered pair for us to plot on the graph. In step 4, we're going to calculate the x-intercept by letting the y value equal 0. Again, that's going to generate possibly two ordered pairs for us on our graph. In step 5, we'll calculate the vertex point. The vertex point is the turning point of the parabolic function. That is, it will determine where the function changes from being an increasing function to a decreasing function. In step 6, we'll organize our calculations in a table of values. In step 7, we'll plot the ordered pairs from the table and graph the function. We'll include axes labels and titles. So whatever variables we assigned for step 2, we'll be using those same variables to label our axes. We'll determine the domain and range that are appropriate for the given function as well. The procedure for graphing quadratic equations by finding the x and y intercepts and the vertex point are as follows. For step 1, we're going to find the y-intercept, and we'll have that calculation already. Step 2, we're going to find that x-intercept, so we can plot that. In step 3, to find the vertex point, we use the formula x equals minus b over 2a. Now keep in mind this only gives us the x value, so we will take that x value and substitute that x value back into the equation to find the corresponding y value. So that will generate an ordered pair for us. And finally, step 4, if we plot all the ordered pairs from the previous steps, we should end up with a graph of our quadratic function. In our first application, this is a problem related to business. The cost C in dollars of manufacturing X bicycles at Grover's production plant is given by the following function. C of x, notice that's function notation, C is a function of x. So C of x equals 2x squared minus 800x plus 9200. Our first question is, what is the y-intercept? So our y-intercept is found by letting the x value equal to 0. So we'll evaluate this cost function with an x value of 0. So we'll have 2 times the quantity of 0 squared minus 800 times 0 plus 92,000. When we square 0, we'll have 0. Multiplying 2 by 0 is also 0. So this first term eliminates. 800 times 0 also is 0, therefore it eliminates, and we're left with 92,000. So our y-intercept is going to be the ordered pair 0, 92,000. In question 2, we're going to determine the vertex point. So remember, x is equal to minus b divided by 2a. So we're going to get the values for a and b based on the original function. It is quadratic, and it's in the proper order from the highest to the lowest degree. So the value for a is that lead coefficient, b is our middle coefficient. And at this point, the last term would be c, but we don't need that for the vertex point. So let's make our substitutions. Minus times b would mean negative 800 is our substitution for b, divided by 2 times the a value. So that's 2 times 2. So we have a negative multiplied by a negative, which gives us positive 800, and we are dividing by 4. So 800 divided by 4 would give us 200. Now keep in mind 200 is simply the x value for the vertex point. So in order to find the corresponding output, I'm going to use 200 back in the function, and we'll evaluate our function with the x value of 200. So c of 200 would equal 2 times the quantity of 200 squared minus 800 times 200 plus 92,000. Following our order of operations, we need to do the squaring first. So 2 would be multiplied by 200 squared, which is 40,000. Negative 800 times 200, and that would be negative 160,000, plus our 92,000. So we're ready to multiply 2 times 40,000 would be 80,000 minus 160,000 plus 92,000. So when we evaluate this function with an x value of 200, our output is 12,000. So this is the y value of the vertex point. Let's place these ordered pairs in our table so we won't need to be hunting for those later. In question 1, we had x value of 0 and our output was 92,000. And we just now generated the vertex point. When the x value was 200, our output was 12,000. Okay, so I'm just going to make a note. That's the vertex. And that first ordered pair was our y-intercept. Question 3. What is the cost of producing 400 bicycles? So 400 bicycles means 400 is the input, because back in the scenario, x represented bicycles. So we're going to have an input value now of 400. So looking at question 3, so we're looking at the function now being evaluated with x value of 400. So 2 times the quantity of 400 squared minus 800 times 400 plus the 92,000. So now that we've made the substitutions, we'll use our exponent first. 2 times 400 squared would be 2 times 160,000. Then we have negative 800 times positive 400. So that was going to be subtraction, and that is subtraction of 320,000. And finally, we have our plus 92,000. 2 times 160,000 is 320,000 minus 320,000. That's interesting. Plus 92,000. So these first two terms are going to be eliminated, and we're left with our 92,000. So when the input was 400, our output is 92,000. In question 4, how many bicycles can be produced at a cost of $50,000? Round your answer to the nearest whole number. All right, so this time we're given a cost. So instead of writing C evaluated with an x value, we already know that 50,000 is what must be equal to the function. And that function is 2x squared minus 800x plus the 92,000. So we have a quadratic equation. It is not in standard form. We'll need to subtract 50,000 from each side. So now 0 equals 2x squared minus 800x, and that equals positive 42,000. In order to solve our quadratic equation, we can use the quadratic formula. And before I use the quadratic formula, I'm noticing that each of these coefficients is an even number. So if you like working with smaller numbers, you could first use greatest common factor. And if I factored out 2 from each term in this quadratic equation, I would end up with x squared minus 400x plus 21,000. So I have much smaller numbers now to use in the quadratic formula. So A will be 1, B is negative 400, and C is 21,000. We're ready to solve using the quadratic formula. So x is equal to minus b So it would be minus the negative 400 plus or minus square root of b squared, so the quantity of 400 squared, minus 4 times a, which is 1, and c is 21,000. And all of those terms are divided by 2a. So the x value is going to be equal to positive 400 plus or minus the square root of negative 400 squared. So that is two quantities of negative 400. That would be 160,000. And then we have our three factors. Negative 4 times 1 times positive 2100. So we have a negative times a positive times a positive. So we will be subtracting. So 4 times 21,000 would be 84,000. These terms are all divided by 2 times a, which was our 2 times 1, so that's 2. So let's simplify what we have under the radical. 160,000 minus 84,000 will be 76,000. We'll need to convert the square root of 76,000 to a decimal in order to use this numerical value. So with your calculator, find your square root function, and I'm going to round to the nearest whole number. It is about 775.7. So I'm going to use 776. Going back to our expression then, x is equal to 400 plus or minus 776, all divided by 2. Now we'll be able to break this apart with that plus minus sign to come up with the two different x values. We'll have x equals 400 minus 776 divided by 2, and x equals 400 plus 776, all divided by 2. When we use subtraction, our answer is 62. When we use addition, our answer is 338. So going back to the table, these are x values. Let's put 62 and 338 in the column for x. But be careful when you're filling in that cost amount. What cost generated these x values? So if we go back to the beginning of the problem, it was 50,000 for that cost. So 50,000 is the corresponding y value. So these are two more ordered pairs that we've generated for the graph. When we get to question 5 for stating domain and range, I always prefer to get that information from the graph itself. So we'll come back to number 5. Let's plot all of our ordered pairs, and in order to do that, we have to determine how to label axes and even where to draw the axes. So in a sense, domain and range are coming into play here. X represents number of bicycles. Could you have negative bicycles, 0 bicycles, positive bicycles? That's what we want to be thinking about. So negative bicycles would not make sense. Only 0 bicycles or a positive number makes sense. So that helps us think about domain. Must be 0 and going to larger numbers. Cost in dollars is our output. Would you have a negative cost involved with making these bicycles? It's not going to cost negative dollars to manufacture these bicycles, so we're looking only at positive values. So we want to use just the edges of our grid. So along the bottom is the input, and that is x. And then we're going to have the other axis going along this edge, and that's going to be our output or cost function. So I've just labeled each axis using a variable, but now I'm going to title them as well. So we have number of bicycles for one title, and we're going to have total cost in dollars for the other. We'll also need to come up with an appropriate scale. Again, we're always starting with 0, so I can put 0. And then looking at our input values, 0 is the smallest and 400 is our largest. So we need to make sure that whatever scale we're choosing will accommodate a number as large as 400. So I'm going to count by 25s. So if each line is worth 25, then I need to be consistent with counting by 25s. 25, 50, 75, 100. And I'm not going to label every line because that will get really messy. For the cost axis, I'm going to look for the smallest value here is the 12,000. But since we're starting with 0, we're already going to accommodate that number. 92,000 is the largest number that we'll need to accommodate here. And since that's a pretty large number, I'm probably going to have to start with counting by 5,000s. So the next line would be add another 5,000, so that would be 10,000. So now I can skip every 2. There's 20,000, 30,000. So I'll number all the way up just past 92,000. The line just past 90,000 would be 5,000 more, so that would be 95,000. And that's high enough. We only need to go to 92,000. So we're ready to plot the ordered pairs. The first one is 0, 92,000. So somewhere between 90,000 and 95,000. That's the best we could do. The next ordered pair is 212,000. The next ordered pair is 400, 92,000. The next ordered pair is 62, 50,000. Do you see the parabola taking shape now? And finally, 338, 50,000. So we can see our vertex point is indeed the lowest value in this parabola. So all we have to do now is connect these ordered pairs and we'll see the graph of our parabola. Now that we have the parabola drawn, we need to consider dots versus arrows on each end. For this y-intercept of 0, 92,000, if we continued to the left, that would represent negative bicycles, so that's not possible. On the other end of the parabola, you need to ask yourself, could this parabola continue in this direction? And it could, because you could produce more than 400 bicycles. So we need to use an arrow on that end of the parabola only. Now this will help us to determine the domain and range. So for question 5, our domain deals with input, or x values here, number of bicycles. So if we look back to the graph at the number of bicycles, we had 0 as our smallest value for bicycles produced, and as we go to the right the numbers increase, and since there's an arrow it goes forever. So the domain would be from 0 to positive infinity. Notice there's a parenthesis with positive infinity to show that it continues. For the range, this is our output. Our output is the cost. The lowest cost is found here at this vertex point. So to know exactly what that value is, we can go back to our table here. X value was 200 and the output or cost was 12,000. So our lowest value is 12,000 with a bracket. And when we rise, as cost increases, how high can we go? It's not going to stop with this dot. We have an arrow. So the cost is going to increase with the more bicycles that are produced. So again, that would be infinity with a parenthesis.